In Unit C of Algebra 1, students spend the first half of the unit connecting function notation and graphs to real-world situations. They use what they know about the real-world situation to describe graphs using math vocabulary. Students then apply their knowledge of properties of graphs to compare situations using function notation. In this video, we will be taking a look at Lesson 5, Practice Problem Number 1, which is about turning a real-world situation into function notation, and then using function notation to compare companies. Take a moment to read the task and also the problems that students are asked to solve. As we look at the task and the problems that students are solving, there is a lot of notation to take in. We see the notation of C of 2, C of 4, C of 5, C of G, and so on. This is called function notation. Function notation is a quick way to name a function, describe its input and output, and is read as, for example, this one is read as C of 4. Function notation is not multiplication, even though we do use parentheses as multiplication in other contexts. Part A of this problem says to write a sentence describing the meaning of the statement C of 2 equals 40. Again, function notation tells us information about the name of the function, the input of the function, and the output of the function. So this letter at the beginning, the C, is actually the name of the function. So this function name is C. And if I look here, it says Rule C gives the monthly cost in dollars of using G gigabytes of data on Company C's plan. So that means that C stands for Company C. So we actually know which company we are working with just from this letter C right here. This 2 is the input. This is what goes inside of our function to give us our output of 40. And the sentence right here that we just read actually tells us about the name of the function, the input of the function, and the output of the function. Rule C is the name of the function, so I'll write that here, that's my name. Gives the monthly cost. So that means whatever Rule C equals is the monthly cost. So this actually right here, the monthly cost, is my output. In dollars of using G gigabytes of data on the Company C's plan. So right here, this G gigabytes of data, this is the input. So using that information here, I can actually write a sentence about what this is talking about. So using Company C's plan, my input is 2, and we said input is gigabytes. So using Company C's plan, 2 gigabytes, and our output is 40. We said output is our monthly cost. So 2 gigabytes will have a monthly cost of $40. And this is all that function notation is. It's just a shortcut for us to write this entire sentence here, but using math notation. And as we can see, the math notation is much shorter than the sentence. For part B, this asks students to compare two cell phone plans, C of 4 and D of 4. As the 4 is inside the parentheses, we know this 4 is the input for both of these functions. We actually know how many gigabytes we are using in both companies' plans. What we don't know is the monthly cell phone bill for both plans when we use 4 gigabytes of data. If I go back to the question stem at the beginning, I can actually write an equation for Company C and write an equation for Company D because it does give me information about each company. So it says here that the cell phone plan for Company C costs $10 per month plus $15 per gigabyte of data used. And this follows from Unit A, where students are writing equations based off of real-world situations. So we know that Company C is going to cost $10 per month regardless of how many gigabytes of data we use. It's also going to have plus $15 per gigabyte. So I'm going to put 15G here just to say it's $15 per gigabyte. And I know we know how many gigabytes were used in this problem, but we can use this equation in other problems such as C, D, and E to help us solve those, so it is helpful to have a generic equation to begin with. But for this problem, we do know that we have 4 gigabytes. So I'm going to put 4 in for G, so it's just substitution, and I'm going to do that every single time I see a G. And what this is on the left, this is just saying that if we have Company C and 4 gigabytes, the right side of this equation is going to tell us how much money we are going to spend that month. And this is something that students can put in their calculator if they're using calculators, or they can know that 15 times 4 is 60. So this is going to become 10 plus 60, otherwise known as 70. So at 4 gigabytes for Company C, we are going to be spending $70. Now for company D, we're going to go back to the question stem here, and it says the plan from company D costs $80 per month with unlimited data. So again, I am going to just write a generic equation just so I can use that for later problems. So company D, if we don't know how many gigabytes we're using, it's going to cost $80 regardless of how many gigabytes we use. And this time it says unlimited data, so we don't actually have an extra charge if we're using 2, 3, 4, 100 gigabytes of data. So this is actually just the equation for company D. It's always going to cost $80 no matter what. If I substitute 4 in for G, again, every single time I see a G, I replace it with 4. On the right side of my equation, I don't have any G's. And that's okay. It doesn't always have to have a variable. So to answer this question, which is less, C of 4 or D of 4, C of 4 is 70 and D of 4 is 80. So it's actually that company C is cheaper when we use 4 gigabytes of data. Part C is very similar to Part B, except instead of using 4 gigabytes of data, I'm using 5 gigabytes data. Part D says, for what number G is C of G equals 130? For this part, notice how we don't have a number inside the parentheses. Inside of my parentheses is a G. A common mistake for this problem is to substitute 130 into the equation for G, just like we did for Part C and Part B. But we have to keep in mind that 130 is not inside the parentheses where G lives. Instead, the 130 represents the monthly cell phone bill for company C. So what we actually have to do is we have to find how many gigabytes of data we used that would give us an $130 cell phone bill. So something that I like to do is I just like to rewrite the question. So I have C of G equals 130. And a little note to myself here that I don't know what G is. So I just put a little question mark there. And what this question is actually asking us is what value of G makes C of G equals 10 plus 15G, which is just my original equation, my generic equation here, equals $130. So a way that students may solve this is by using guess and check, where they use their calculator and they put in a number for G. So let's say they tried 6 and try to see if they get 130 as their answer. So 6 is not how many gigabytes were used because this is only giving us $100. Another way students might solve this is to use their reasoning about the situation to break apart the problem. For example, a student might reason that $130 is made up of 10 plus the cost of gigabytes. 15G is how much the gigabytes cost. Taking away the $10 from both sides, we have that the cost of gigabytes is $120. Lastly, we know that each gigabyte is $15 and that 15 times 8 equals $120, so we used 8 gigabytes. A third way that students might solve this is to actually solve the equation, and they would use inverse operations to solve for G. And I need to get rid of the number that's not touching my G, that's on the same side of the G, so I have to get rid of this 10. There is an imaginary plus sign here in front of the 10, so to do the inverse operation of plus or addition, I'm going to subtract the 10 on both sides, which is very similar to how the student who used reasoning began. 10 minus 10 is 0. Some students write it as a placeholder, but I'm just going to cross it off. And I have 15G equals 120. Now I know this is 15 times G, so to use the inverse operation of times or multiplication, I'm going to divide both sides by 15. And if we do 120 divided by 15, I end up with 8 gigabytes. A fourth way a student might solve this is by graphing. And we will actually see graphing in Part E, so I'm just going to move on to Part E then. Part E asks us to draw the graph of each function, and I did color code this here just because we're going to be graphing 2 lines on the same grid, and it is helpful to understand which line is which. So if we go back to our equation here, or even back to the word problem, we have our equation C of G equals 10 plus 15G. Typically when graphing lines, we need 2 pieces of information, the y-intercept or the starting value, and the slope or how much the item changes each time. For company C, the starting value is the monthly cell phone bill if we use no gigabytes of data, and that is this $10 here. So I'm just going to graph right here at 0 gigabytes used, we spent $10. For each gigabyte of data we use, we spend $15 more, which is the slope, and that comes from here, 15G. So if I used 1 gigabyte of data, I'm going to spend 10 plus 15, which is $25. And it looks like this scale is going up by tens. So if I'm spending $25, I'm going to be between $20 and $30 here for 1 gigabyte. For 2 gigabytes, I'm going to add another 15 to that. So 25 plus 15 is 40. So 2 gigabytes is going to be $40. And I could just continue this pattern of adding 15 for each gigabyte I use. Connect my points to make a straight line for company C. And for company D, we know that D of G equals 80, and we don't pay anything extra. So if I use 0 gigabytes of data, I'm going to spend $80. If I used 1 gigabyte of data, I'm still spending $80. And we actually see that here that D of 4 equals 80 and D of 5 equals 80. So no matter how many gigabytes of data we used, we're always going to be at $80. I'm going to connect these points with a straight line. From here, even though the task does not ask for it, we can compare these functions using the graph, such as finding the exact amount of gigabytes it would take for both cell phone plans to be the same price, or when is it better to use which cell phone plan based on how many gigabytes of data we used.